All right, everyone. We are live. You know the drill. Let me make sure I can see myself on YouTube. And let me make an announcement over on my original Big Discussions 76 channel. In case anyone over there wants to partake in this. Okay, so we are live. I hope everyone's having a good Tuesday and a good start to your week. Okay, yep, there I am. All right, let me do that. Let me share it. Let's see. Back. All right. Hello, I'm live with a guest. Okay. So that was shared. So if folks want to come over from there, they can come over from there. All right, let me go back to StreamYard. Yep. All right. All right, everyone. I'm going to play the intro. I have a special guest tonight. We're going to be talking a little bit of electrical engineering. So I'm going to play the intro, and then I'll make a few announcements, and then I'll bring my guest up, and we'll jump right in. So I'll see you on the other side. All right. Hello, everyone, and welcome back to my channel. My name is Dr. Anwar Youssef Dunbar, and this is Big Discussions 76, Science and Technology. First of all, please like this stream, please share it, and please subscribe to my channel. Especially hit that like button if you're watching on the playback, and you may consider hitting the notification bell as well. I've been told by folks that they don't get notifications when I click that go live button. So make sure you hit the notification so you know. I'm still learning this YouTube thing as I go along. Well, it's June 14th, 2022. I don't know if you guys can note it, if you notice, but something's a little different here. I actually invested in a desk today, so you won't see the screen wobbling now. And I think this is going to improve the journey going forward. As you go along, you want to make upgrades, and that's an upgrade that I should have made a while ago. So there'll be more upgrades coming in the future. But tonight we're going to talk a little bit of electrical engineering, which is not my specialty, but I'm excited about this because it's one thing for me to get on this channel and talk about my scientific background and to talk about the relevant stories of the day. And I've learned personally that as a content creator, I have to be careful about what I talk about here, because we can't talk about everything here on YouTube. But one of the reasons I started this channel, as I mentioned in my trailer, was for STEM advocacy, especially for individuals from backgrounds like my own. So tonight's show was actually a request from a gentleman named Austin Castro. And Austin reached out to me via LinkedIn and asked me to find and interview an electrical engineer. So this was his idea, and I guess I'll say Austin is the sponsor of tonight's show. So a gentleman from LinkedIn was gracious enough to step forward and say, I'll come forward and talk about my education and my career. And he is going to talk to us about his education and his career. I'm going to bring him up. Before I do, everyone, please consider joining the Big Words LLC Newsletter. I sent the first one out this month, and I think it wound up in quite a few folks' promotions pages in their Gmail accounts. If you signed up and you didn't see it, check the promotions page or folder of your email account. Check the spam, check the trash, the junk. That's probably where it went. But there's a greeting there, and there is a subscription button there at the bottom. So with that, I'm going to minimize this. Also keep in mind that I don't have a super chat over here or a super thanks. So if you're watching live and you want to make a donation, or if you're watching on the playback and you want to make a donation, my Cash App and PayPal are right there. Also, the link for the newsletter is right here as well. I'm going to drop that in the chat. In addition to YouTubing, I do a lot of writing as well. So with that, everyone, I'm going to bring up my guest, Yvonickel Saint-Cyr. And he's going to talk to us about electrical engineering. I have some questions from the show sponsor, and I'll probably ad-lib these, and when things come to me, I'll probably add to them. But I'm going to bring up Yvonickel Saint-Cyr, and we're going to talk about electrical engineering. So, Yvonickel, welcome.
Hey, thanks for having me.
No problem. Thank you for volunteering.
Mm-hmm.
Okay. If you don't mind sharing, where are you based out of? You out west? You in the east and the Midwest? Where are you?
I'm in the East.
Okay.
Mm-hmm.
Okay. It's scorching here in the DMV.
Oh man, it's so hot.
Yeah. Okay. Well, question number one. You've seen these. it deals with your background. It says, "What is your alma mater?" Well, you know what? Let me ask you this, Nikel, because I just had a stream on this
Hmm.
on it was Sunday, Saturday or Sunday. I did a stream on the culture of science, and I was talking about the backgrounds we come from and what it means when you launch into a science and technology career. So you're an electrical engineer, which means your curriculum was full of mathematics. Your
Hmm.
curriculum was full of physics. In addition to your engineering courses, there's probably some chemistry in there as well. Talk
Hmm.
about your educational background. You revealed to me that you were of Haitian descent. Did they push education pretty hard? What was your educational background like?
Um, yeah, I'd say my parents definitely pushed education for me, higher education after high school. Actually, back in Haiti, my dad was a math teacher, so I definitely looked up to him for that. Um, and growing up through grade school, middle school, high school, um, I was a pretty good student, especially my early years towards high school. You know, just different peer pressuring activities, different just growing up through life. So my grades kind of suffered. I wasn't as good of a student as I used to be. I wasn't as great at mathematics as I wanted to be. While I was in high school, I think I was taking AP classes. It was AP Calc, and I think I almost failed that class. And that was kind of a wake up call for me because I had a thought that if I almost failed this class in high school, I wonder how I'm going to do with mathematics in college. Um, but yeah, my parents pushed me to go to higher education, and I mean, they, yeah, that's about it.
Well, what was it like growing up with a math teacher as a father?
Um, it was interesting because he was a math teacher such a long time ago.
Mm-hmm.
So I guess the math, I'm not really sure what grade level he taught, but I think by the time I got into high school, what I was doing in classes, he wasn't exactly familiar with. So I'd say the experience was still just about the same as most parents. They're not really sure of what how to help you.
Mm-hmm. Yeah, yeah. Certainly, curriculums evolve. The way things are taught evolve. I know that the major buzz a few years ago was the Common Core. So I think
Hmm.
there definitely was an evolution in the teaching of mathematics, as there is with most things.
Hmm.
Okay, and I think it's worth noting here. I have a PhD in pharmacology. My history with mathematics is very, very mixed. I was an unfocused student in K through 12. I did really well in pre-cal 2 when I transferred to Johnson C. Smith University. And then when I took Cal 1, I just completely bombed. But it was because, and my professor pointed this out, he said, when you took pre-cal 2, you were in the office with me every day. Okay.
Hmm.
This semester, you haven't been. And so, no, I wasn't spending as much time with Dr. Alexander. I don't know if he's still alive, but that time in his office afterwards, I think was important. And so when you do mathematics, the repetition, the practice is important, but also that time with the professor is important. And then not if you're successful at it, not changing what made you successful. So
Hmm.
okay. So
Yep.
yeah, so Austin asked, this is going back to your background. What is your alma mater, high school and college? Are you from the Northeast? Did you grow up in the Northeast, or did you come straight from
Uh,
Haiti?
I grew up in the Northeast. I actually was born in Boston, and I moved. But my alma mater high school is Arabia Mountain High School.
Which one?
Stonecrest, Arabian Mountain High School.
Arabian Mountain. Okay.
It's a charter school in Georgia, in Stonecrest, Georgia.
Okay.
If I remember correctly, there were three different, I guess, educational tracks you could go on. You could go on the business track, the engineering track, or the agriculture track. I took the engineering track. Um, I graduated there with just like a few AP credits, but they didn't really amount to anything in college. Where I went to college was Georgia Southern University down in Statesboro, Georgia.
Mm-hmm.
I, I got my bachelor's of science in electrical engineering. I didn't graduate with any special honors besides being in a fraternity. Um, and my final GPA, I believe, was a 2.69, I think.
Mm-hmm.
And that's it.
Okay. What influenced you to become an electrical engineer?
Um, I'd
What
say
motivated
I
you?
was I was mostly influenced by my upbringing. We had things around my house when I was younger that would break, and me and my brothers would be the ones to take pride in taking them apart and fixing them. Um, I also had an interest in computers at the time, which I'd say was kind of a natural progression to electrical engineering.
Mm-hmm.
Just because when I was fixing things when I was younger and then getting more acclimated to technology, I just wanted to fix the technology I was using so I could use it more, I guess.
Okay. Before we move on, talk about, for those not familiar with it, talk about your curriculum at Georgia Southern in that engineering program. What kinds of courses did you take?
Hmm. Um, so starting off, I'd say the course load wasn't that bad. You have your English classes, um, like those core classes that you're required to take, no matter what major you're in. So like English classes, like think like a health class. And for my school, there was like some special elective classes, um, psychology or public speaking,
Well, how
and
about
then
your engineering curriculum? What was involved in that? Was it
mhm.
some GChem, some physics, calculus? What? Yeah, tell
Yep,
us.
yeah, there was some general chemistry. There were actually two versions of that class because there were the non-STEM majors that had to take chemistry, and they took I think it was a trig-based chemistry. Then for engineers, they had a calculus-based chemistry, which was a little bit harder, I believe.
Mm-hmm.
Um, we had pre-calculus, calculus 1, 2, and 3, physics 1 and 2. Um, those were the main math. Uh, those were the main, I guess, precursor courses to my engineering. After that, I was taking mostly engineering classes. Introduction to MATLAB, introduction to computing, which was like learning binary and learning logic. Um,
Okay, but before we jump into that, so does that mean you had prerequisite courses before you could get into the engineering school?
yeah,
Okay.
hmm because for those prerequisite courses, you needed a certain GPA in those courses in order to take the next course. Mhm.
Okay. So what was all um so go ahead. What was all involved in the electrical engineering curriculum? Because I'm not familiar with what all goes into that.
hmm So yeah, like I said, intro MATLAB, which was like uh, um, math software, to do complicated equations. Um, intro to computing, which is logic and learning binary, just like the basics of how computers were started. I had some basic classes. I think it was Visual Studio. We also had a course in microcontrollers, and that was a little bit more advanced class. It was building on what I learned in my intro to computing. Actually putting that to practical use. I got to work on little projects, logic projects, where I ran code. I used code to, I guess, control certain things that were kind of pre-made. For example, we had a kind of like a train simulation, and although I didn't make the code from the ground up, we learned the basics of the logic to have that simulation operate in a certain way so that there were no conflicts with the logical train that we had. So I think that was a pretty good course for me to learn. Um, in addition to that, what else did I learn? Um, there were some other courses. Oh, some more higher level math courses like differential equations. Um, that was, I'd say that was kind of a difficult course. That one in Calculus 3. Actually, Calculus 3 was one of the harder courses for me,
Mm-hmm.
um, because I ended up failing it 3 times. No, 2 times. I failed it 2 times. And I told myself that if I failed it again, I would have to seriously consider switching my major. And at that time, I was just really uncertain. I ended up being able to pass it, and I moved on. Once I got past Calculus 3, I took differential equations. Once I got past that, I think I was pretty much done with my math classes. Um, and it was just mainly engineering courses. Courses like, hmm, there are more coding classes, or logical based coding classes to help build on that logic base. Circuit analysis, just learning the basics of electrical engineering, and like designing circuits. Because I think one of the most important classes in the curriculum was circuit analysis 1 and circuit analysis 2, because although it doesn't show you every single type of situation you'll run into as an electrical engineer, it builds the basis for you to help you figure out how to deal with a lot of situations. Um, I also took a course called microelectronics, um, and that was mainly a course teaching me about like certain circuit components rather than just the circuit as a whole, learning how this particular circuit components work, um, their properties and whatnot. I also learned about electrical systems as far as like transformers and like transformers that are used in power plants.
Mm-hmm.
I learned about that. Um, and there were some other classes I don't quite remember, but
Okay.
um,
Well, yeah, I just want to give the layperson, the person unfamiliar with this, just a sample of what you learned. It sounded like you. I'm surprised to hear that you were learning some coding because I would think that that would be something a computer programmer or a computer engineer would have to know. But electrical engineers need to know that too.
um, not necessarily, but in my experience in the industry so far, coding is helpful because it's sort of an interdisciplinary thing where it's not needed to be an engineer, but
Mhm.
in there are certain types of situations or softwares that use coding in them, and it makes it a lot easier for you to work if you already know how to use it and or use that code. Um, yeah.
Okay, before we move on, I want to get through all of Austin's questions here
Hmm.
and not overwhelm this with my own. What um what was your secret for passing calculus 3? I mean I dropped cal 1, but you went on to calculus 3. What was your how'd you do it?
Honestly, I'd say I got lucky because I know the first time was, I think I just didn't study enough. The second time, I took it over the summer, and the pace was just way too fast for me, and I just dropped it. So then the third time, I got a teacher that was a bit easier, um, and then again, then it was during a longer semester, so it wasn't as faster paced. Um, and I just took a lot of time just trying to um, understand each part of the problem. And that's something that I did in a lot of my studies because I think after Calculus 3, I started doing better in my math classes. And honestly, I think if I took it now, I would pass it the first time for sure. But I'd say some of what I did was just learning to understand the problems in my own way and try to learn how to make natural connections in the problems so that it doesn't matter if I come across. I'm not trying to memorize how to solve a problem. I'm trying to understand how to solve a problem. And the difference between those is that if I come across something unfamiliar and I've memorized how to solve it, if I haven't memorized how to solve that particular problem, then I'm stuck. But if I understand how to solve that problem, then it provides me. I might not even be able to solve it, even if I understand, but it'll still bring me some steps closer to being able to solve that problem.
Okay, that's interesting. So you're not, you say you're not trying to memorize how to solve the problem. You want to understand how to. That means you can work your way through it somehow.
hmm And yeah,
Interesting.
sure, there are like formulas and things that you probably need to memorize, but for the majority of it, and honestly, for a lot of my classes, you were allowed formula sheets. So I would get the most important formulas, and usually use that were used in the test. But even then, understanding it is a bit better than just memorizing it. Mhm.
Yeah, yeah. They I remember my physics professor in college. He allowed us to bring a formula sheet. So if you knew which
Mhm.
formula to use, then you're pretty much golden. Let's see. Austin says, I've seen a lot of schools combine the two disciplines. Hence, a person might graduate with a degree in computer and electrical engineering. Okay.
Mhm.
The next question is, okay, I don't think we answered this one. What influenced you to become an electrical engineer? What made you decide to get on that path and stay on that path?
Oh, actually, I think we didn't answer
We
that.
did. Okay, let's move on
Mhm.
then. I'm sorry. I
Okay,
apologize.
no, you're good.
Um, was there ever a time where you felt like studying electrical engineering wasn't for you? Did you ever have doubts?
hmm Yeah, well, when I took that Calculus 3 class, um, and when I did fail it the second time, that was the same semester that I had taken econ, and I got an A in econ. And I believe the department head for the econ department was they sent me a letter or email saying that I should consider being a major or minor in econ because I did so well in the class. And so I said, if I fail calculus again, I might have to become an econ major.
Hmm.
hmm
Okay. The next question is, and that's a science all in itself, in my
hmm
opinion. Did you have mentors during the
I
process?
I didn't have any mentors. I
Really?
actually didn't really associate with my peers and that were in the same major as me until my senior classes. Like I think my last year. I'd say the reason for that is I was pretty heavily involved with band in my fraternity that I was a part of, so I didn't even consider uh, associating with my classmates at that time.
Okay.
hmm
Okay. Interesting. Let's see. How? Let's see. How are you able to specialize in a specific niche in such a vast field? I'm assuming you have a niche, um,
Um,
or do you?
I mean, I guess people might. kind of say it's a niche. I don't know if I would say that. Um, the where I work in the industry now is automotive. I work for a company called Panasonic. Um, and I'm not like I'd say what I'm doing now is more of a, I guess an assistance role. Like what I'll do is I'll keep track of some of the inventory we have, um, and then I'll run tests for the more senior engineers, whether they need me to take something apart and like look at specific test points on a board. I've done that, or just different soldering tasks, smaller tasks that help the more senior engineers to focus on the higher level tasks. Um, and as far as specializing in this, I didn't necessarily have this destination in mind um, when I got here. It was really, I'd kind of say it was a stroke of luck. When I graduated from Georgia Southern, I had a fraternity brother who had some connections and was able to help me land my first job. Um, and at that first job, it was a pretty good gig. It was actually working for the government. Um, it was a contract position with the company. I worked there for 2 years, but during that second year, I'd say my career progress stalled. That was actually during the height of the COVID pandemic.
Mm-hmm.
Um, so I'd say slightly because of that and just things related to it, I'd say my career progress stalled. So basically, what I mean by that is I would go to the office and the kind of tasks I was given for my contract weren't exactly what I wanted to do as an engineer. It was an easy job, but it wasn't fulfilling. And so during that time, I was passively looking for jobs. Um, and I eventually was able to land this job at Panasonic. Um, and I just was open to receiving those opportunities. And so I didn't necessarily choose a specialization, it chose me.
Okay. Can you? And I know there are concerns for intellectual property and special projects. Can you
Hmm.
talk to us a little bit about, because Panasonic? When I think Panasonic, I think, well, yeah, electronics,
Hmm.
TVs. I don't know them for cell phones, but appliances,
Hmm.
those kinds of things. Can you talk to us about what you're doing there, or what you guys are making?
So since I'm in the automotive division, we're working on car components. And how it works for us right now, like we have a lot of customers, like from Tesla to Audi,
Oh,
Chrysler, Honda, just most of the car brands. But it's not like we're building the whole car or anything. It's like we're providing a small piece of a bigger system. And so that's kind of providing a small piece of a bigger system. Actually, could you repeat the question?
I was just asking if you could say a few words about what you guys are making there, because uh, you guys are. It sounds like you're making products for Tesla. You're making car pieces, or pieces,
Hmm.
components, car components, right?
Yeah, yeah, okay. So yeah, like I was saying, we're making small pieces of a bigger system. Um, and that kind of is just building your own piece of technology and then learning how to in integrate it with different parts in different companies' hardware. I think that's where a lot of it goes into because sometimes we'll have issues with a certain part that we're using. For example, I don't know if I can go into it in that much detail. I probably shouldn't, but
Okay, be careful.
mhm, for auto manufacturer and and basically we're just it's like a new feature to provide more convenience for the user. Um, I guess sort of something like a heads-up display, futuristic type things, not quite that far in the future.
Okay, you froze a little bit in there, so it was hard to hear exactly what you
Hmm.
said. Could you repeat that?
Yeah. So like I said, we have customers like Toyota and Tesla,
Mm-hmm.
and some of the things that we're working on are to increase the convenience of the consumer. For example, say you have like a heads-up display in your car,
Mm-hmm.
but not like a third party, but something that's provided actually by that manufacturer. We're working on features like that, or maybe you have a camera on the back of your car, and rather than it showing up on the dashboard, maybe it shows up on your rear view mirror.
Mm-hmm.
Special things like that, just to make it more convenient and more safe for consumers. Though personally, I'm not really working on those. I'm kind of supporting that.
Okay. Let's see. This question says, most people make engineering about obtaining a job. Have you been able to make a contribution to your field of study? So I guess are there any special projects you're working on, or is there anything unique that you've created or generated or worked on?
Um, Honestly, no, not at this point in my career. I haven't had a chance to really contribute to anything. Um, though I do like this job because the engineers that I work with, they're very open to mentoring and investing in the employees that they have. So I'm confident that if I do put in the time and effort, I will be able to make some contribution, and maybe not in the entire field of electrical engineering, but possibly in the automotive sector in some form or fashion. I think so.
Okay. This question says, how do you use the topics that you learned in your career? Parentheses, examples, mesh, Thevenin, and reactive power. Those are things that I'm not familiar with. Are you familiar with those?
Yeah, I am.
Okay. What are what can you explain what those are?
Yeah. So when I was talking earlier about circuit analysis being one of the courses I took in my curriculum, um, Thevenin's um, Thevenin's equivalent, Norton's equivalent. Those are things that are used to reduce complicated um, complicated problems or complicated diagrams into more simpler ones that can be more easily analyzed, because there comes a point where the things that we're making are so complicated we can't even understand them in the form that they're in. So we need to reduce them. We need to find ways to reduce them to make them simpler, for us to kind of look better at them. As far as using those every day, I actually don't use all of those every day or even every week, but when those kinds of things do come up, it is kind of expected that you're not unfamiliar with them. You have some sort of base of knowledge on uh, most, if not all, of your coursework. Um, Obviously, depending on the industry, electrical engineering that you go into, that will determine what that should give you an idea of what exactly you need to focus on. Um, and honestly, the industry is different because they don't really tell you use this formula or here's a concept you need to think about to solve this problem. I mean, albeit they will have someone, like there might be a more senior engineer who's willing to help you with that and give you those answers, but you won't necessarily get those. And so you need to be able to break down whatever task you have into the simplest form you can make it, and then when you're building it back up, as you're building it back up, you can you'll be able to figure out what concept you need to use, as far as Thevenin's equivalent or max power theorem. um, and that's just one of many different concepts that we learn.
Okay. Got three more here.
Hmm.
This question says, "What is the best CAD program to learn? Multism, Cadence, or MATLAB?" And I know CAD means computer automated design.
Yeah.
My brother was studying architecture at one point. So, but anyway,
Hmm.
what do you think is the best to learn?
Um, this field is so broad. It's honestly like even just in the automotive industry, it's hard to really say what's the best. But my advice is that you should find a program that you like or you find interesting, and then ask your teacher, or if you're not in school anymore, ask a coworker about it who knows more about you. Ask them about how it works and how it would be used in the industry. Also, you can look at lots of job descriptions for jobs that you might want. And those job descriptions usually will have some sort of software. Um, and going back, if I were to be getting out into the workforce again, what I would do is I would look at different job descriptions and see what softwares they're requiring me to learn, or they're saying, "Oh, we want this as a plus," and I would kind of aggregate and see which is the most popular among these, and that would kind of give me a idea of which one is probably the best because it's used by m- more companies. Um, because personally, I've only really familiarized myself with a program called Multisim, and that just helps you build circuits and simulate them. But that's about as far as it goes. It's not quite as much of a full package as a program like Altium. It helps you build circuits, um, s- simulate them, and then build the package to bring that design into the physical realm. And it like helps you be able to convert it into those ways. So also that's why it's kind of difficult for me to answer because I don't really use that much software, or I'm not really an expert at any particular software. I have kind of like a base level knowledge of some softwares.
Okay. This question, this is the second to last question. It says, if a person, and I don't know if you've pondered this yourself, it sounds like you're still early in your career,
Hmm.
but it says, if a person wanted to go into business for themselves, what skills acquired in school would be the most useful? Have you thought about going into business for yourself at some point?
Um, I have, but not really in the engineering industry.
Okay.
But even still, I'd say that management skills would be the most useful. From my experience, when you can manage people efficiently and have them work together to reduce redundancies that waste time, that
Mm-hmm.
creates that creates a productive team. Because a lot of the things that I would, because the role that I have with my current company, um, I was an inventory manager, and I was almost like a kind of like a point man for everyone on the different teams. So if the software team needed something, they would, or for certain things, I would be the point man. If they needed something, they would come through me. Um, and just a lot of different people came through me, and I got to see firsthand how redundant some things became, where someone would ask this person for how do you do this? How do you do this? They would explain to them, but then there was no, I guess, there was no main place that we could go and look, that everyone could go and look. Or if there was, they just didn't and they didn't know. But there was no main place everyone could go and look to see that, oh, this is how you do that. There was no documentation on how to do certain things sometimes, and I was tasked with that sometimes. I'm creating that documentation. or being the person who helps get someone set up with certain equipment or certain software. Um, just having systems to reduce that would be good for helping start a business.
Mm-hmm.
Um, yeah. Mhm.
Okay. Before I ask the last question from Austin, um, UFO Kamikaze One, that's a unique name, says DuPont sold the site I worked at to DAC America. I saw the writing on the wall and departed before they hit the iceberg. Okay, that's fascinating. Gold Professor says, question. This is also for you, Dr. Dunbar. So it's for me too. But were there more men or women in your classes during the time you both attended school? Uh, Nikhil, I'll let you go first.
Okay. Yeah, there were definitely more men. I'd say in each of my classes, there was one, maybe two, between one and three girls in each of my classes, but I'd say the average was probably one, at least in the engineering classes.
Okay. Now you said Georgia Southern, right?
Hmm.
Is that a STEM school like Purdue, or is it just a general? Do they have a lot
Um,
of humanities there and uh,
hmm, I mean, I don't know if it's like a super renowned STEM school, but I know that like they have a lot of people that come from Georgia Southern and work at like different electrical firms like Georgia Power. So they have a pretty solid reputation with some of those companies. So Georgia Southern, I don't think is necessarily a strong STEM school, but they have
mhm.
a strong electrical engineering program for sure.
Okay. Now for me, as an undergraduate at Johnson C. Smith University, I think we had more women. We had more females there. When I got to Michigan, I think it was an even split. I think it was an even split. But then you're going from an HBCU to a Big Ten PWI, so your
Hmm.
demographics change quite a bit there. So,
Hmm.
um, let's see. Professor Black Ops says I teach cybersecurity, more total men, more black women than men. Interesting. Okay. So the final question, Nikel says, concepts learned in engineering can often be learned superfluously. How did you train properly? Okay, so I have to superfluously. I'm thinking back to what does that word mean? I'm thinking redundant. I'm thinking extra.
Yeah. Hmm.
Okay.
Yeah, that's what it means. Basically, that some of the things that we learn might not be necessary. But to that, I'd say I'm not really sure if that's true because I feel in school that a lot of the things that you're going over, yeah, it is very broad, but I think that's to help you get a taste of your strengths and weaknesses, to help you figure out what you like, how to explore them if you're motivated. And personally, I think in terms of technical knowledge and engineering, I'm probably a little behind the other people who I've graduated with, but part of my strengths come in that I'm a quick study and I like to understand things. So though I might not be able to come up with a new device from scratch, I can contribute because I'm not afraid to ask my coworkers for resources that I can use to help me understand what I'm looking at so I know how to move forward. So in order to train properly, I'd say to be curious about your work and have a desire to contribute. In my role, I've gotten lucky just in terms of getting it, but in terms of keeping it and moving forward, I think that being curious and wanting to contribute is something that will help you move forward.
Okay. Yeah, I would say for the stems, that's a general attribute, and I put that on my slide in my
Hmm.
discussion on Sunday. Curiosity, curiosity, curiosity. Go, Professor. He's keeping us in this gender space. He says, "Do you think it was by choice, or more so they weren't interested in the fields you both chose, or was it that they just didn't qualify?" So he's in your um, electrical engineering curriculum. Do you think that that's something that women just weren't interested in, or
Um, I'd say it was a mixture of both. Well, not necessarily that they didn't qualify, but other people thought they didn't qualify.
mm-hmm.
Um, and also that some of them just weren't interested. Um, and so I think just that kind of field in general, I think women are just less interested in it. Um, and hmm,
It's kind of
yeah,
open ended. I mean, you'd have to sit there and pour over the data
uh huh,
and then go out and do
yeah.
a survey. So if you don't have an answer, that's fine.
Hmm.
Let's see. So on my end, again, once again, I went from an HBCU to a PWI, and then when I went into my PWI, they were really picking in a graduate program at a University of Michigan or Ohio State or Northwestern or Purdue. They're trying to pick the best. I'm not saying I was one of the best, but they're really trying to handpick who they think might succeed there. So they brought in some exceptional women
Hmm.
into my graduate program, but at my HBCU, in our Department of Natural Sciences, there were
Hmm.
more females, and I think that was a reflection of the trend, the educational trend that the Black community was going on at that time, because we know that there are more, I believe there are more females in school than males. I think that's what that was reflected of.
Hmm.
Now, everybody in my department didn't go on to have a career in the sciences. Let me make that clear.
Right.
Someone told me at homecoming before the pandemic that I was probably the only one from our group who went ahead and stayed in the sciences. There were some folks, well, and there were women who went ahead. I know one became a medical doctor. Um, some of them became healthcare professionals. They were all AKAs. What organization did you pledge? By the way, was it? Well, go ahead.
It was Kappa Kappa Psi.
Okay,
Hmm.
okay. Let's see. Was that his Austin's last official question? Yeah. So he asks right here in the chat, were you a part of Nesby?
No, I
No.
wasn't.
Okay. Okay. Well, Nikel, those were all of Austin's questions, and I know, again, with you being in the private sector, there are limits on what you can talk about in terms of the projects and the technologies and the intellectual property.
Hmm.
What do you? I get the sense you're still early in your career.
Hmm.
Where do you see yourself, or what do you want to do with the rest of your career? And you might not know that for another 10 years, but what do you foresee at this point?
Um, hmm. So when I first got out of college, I thought I wanted to become um, like a professional engineer
Hmm.
because in uh, there is a national test for engineers. It's
Really?
called the Fundamentals of Engineering exam. That allows you to get your engineering trainings license.
So it's like
Um,
a certification, like the bar or a physician taking their boards, right?
yeah, for this particular one, I'd say it's kind of like the LSAT. Wait, which comes before for lawyers? Is it the LSAT or the bar?
The LSAT's the exam you take to get into law school, and the bar is what you take to actually practice law.
Okay, so yeah, I'd say that the fundamentals of engineering is similar to the LSATs in that it's like a precursor, and that allows you to start your journey to becoming a professional engineer. And basically, once you take that fundamental of engineering's exam and you pass it, you can get that certification that you're engineering training. And I believe it's 8 years working in the field under another professional engineer in the field that you want to work in. Once you have that 8 years, you can take another test called the professional engineer's exam. Um, and there are different concentrations. I think it's like electrical electronic devices, which is like kind of something similar to what I'm doing now, where you're making smaller devices. And then there's electrical power, where it's kind of like commercial buildings, like you'd be the kind of person that signs off on the plans for those, making and certifying that they're safe, they're built to code, they're built properly. Then the last one is computer engineering. Not entirely sure what that's about. But once you can pass one of those exams, you're that's someone that you can that's officially called professional engineer. Um, it's typically accepted that anyone who graduates with a bachelor's or master's in engineering is called an engineer, but a, technically a professional engineer is someone who's passed those exams.
So give
And
them.
they're
I was going to say, give them to us one more time. Uh,
oh,
which
go ahead.
ones? Which ones are they?
The fundamentals of engineering exam. That's the first one that
The
allows you.
fundamentals. Was it
Hmm.
okay? Fundamentals of engineering.
And then the professional engineer exam that
Okay.
allows you to practice engineering in whatever state you take it in, and that actually allows you to open your own engineering firm.
Okay. So this I mean, we're approaching an hour. I don't want to keep you all night,
Hmm.
Nikhil, but this is just educational for me and for all of us. So a professional engineer would either go work for a company like the guys your colleagues. They're professional engineers at Panasonic. Yes.
Actually, no. So one thing that I learned after graduating was that a lot of engineers aren't necessarily professional engineers. They because basically a professional engineer is just someone who has legal, I guess, liability for certain things, and you don't need everyone to do that. You just need certain people to do that. um, Professional engineer is kind of someone who might sit at the head of a board and sign off on plans, but not be the one that's actually making those plans.
So he's a corporate executive. It sounds like,
Yeah, that's what it sounds like
or
to me. Because
he's interacting with corporate executives. He's at the top making decisions.
hmm
Okay.
because I've worked at two companies and I asked about professional engineers and they said that, it's not for what we're doing.
Okay. Okay. So that's what the professional. When you think about professional engineers, that's where you're thinking. You're thinking about in the boardroom making strategic decisions for that given company. Now, can you talk a little bit about an engineering firm? Is this a Are you still there? It looks like you froze a little bit.
Oh no, I'm here. I'm here.
Okay. When you talk about starting a firm, is that, let's say they have a special project, they have special projects that they're working on for um, other companies or cities and localities? Like what does an engineering firm, an electrical engineering firm, what do they do?
I mean, it could be similar to what um another engineering company does, like maybe it could be something that's kind of similar to what I do at my company, or what we do at my company. It's just that it's really just about the legal liability. Like legally, the engineering firm is allowed to be called this and that engineering or so and so engineering. But someone who doesn't have a PE that's at the top of the company, a professional engineer at the top of the company, they're legally not allowed to have engineer in their name.
Okay,
Mhm.
interesting. Okay, I'm gonna let you go in a second, Nikel, but let's see.
Okay.
Uh, go, professor. Okay, so the professors at Georgia Southern, what were they? Were they more men, more women, people of color,
Um,
Asians?
the majority of my professors were
Engineering curriculum.
in the engineering curriculum. They were men. I think I only had one female professor, and the majority of them seemed to be non-white and not black, so maybe Hispanic or some sort of Western. I'm not really sure, but yeah.
Okay, and then let's see. Let's see. Go, professor. The questions you're asking now, I'll just say that I think that a lot of this is linked to reading proficiency and encouraging education. We know that boys and girls learn differently, and if you can't read, that's gonna hinder your ability to get involved in any type of engineering, any type of pharmacology, any type of science. Reading is absolutely critical. So until that problem gets solved, we'll continue to see what we see in terms of what's happening in Black America and boys and girls and why the numbers are different. That's just my opinion. Well, let me ask you this, Nikel. In Haitian communities, is there a
Hmm.
difference between the number of boys that go to school and girls that go to school in terms of higher education? Is it equal? Is it different? What have you seen?
Um, from what I've seen, it's definitely not equal. I feel like there are more women in Haitian communities that are going to school and completing degrees, and even getting even higher degrees, masters, um, compared to Haitian men. So I think that kind of follows what we've been seeing in the black community as well.
Interesting. Okay. Okay. All right. We're at an hour and 4 minutes. And I have to go into the office tomorrow. Nikel, well, first of all, thank you for stepping forward
Yeah, no
and
problem.
volunteering to talk about your background. Certainly, if you want to come back at some point, I'd love to have you back, and
Hmm.
um, I'd like to have more discussions with the tech people. So,
Hmm.
if you have any colleagues who would be interested in something like this as well,
Hmm.
definitely pass my information along. Do you have any parting thoughts or comments?
Um,
What?
no.
Okay, so tell us this: for a young person who
Mhm.
thinks they want to get involved in electrical engineering. Um, so, two questions. Let's just go over again what exactly electrical engineering is. It looks to me like it's dealing with circuits and Circuits are everywhere. Circuits are in this computer. Circuits are on airplanes. Circuits are are in our cell phones. Circuits are everywhere, right?
In buildings.
Buildings,
Hmm.
hmm cars, and everything's getting smaller.
Hmm.
Um, um, so imagine the circuits are getting smaller too.
Hmm.
So
Yep, that's right.
that's what that field is. You're dealing with circuits, the conductance of power through those circuits, and it sounds like since you had some computer programming, it sounds like there's some programming aspects to this as well.
Hmm.
What for a young person? What are some of the attributes they would need to get into electrical engineering and then to succeed in electrical engineering?
Um, I'd say first you need to have an interest in understanding how things work
So a curiosity.
because mhm, at the core of it, someone who is curious and wants to understand how things work will go further in the engineering field, even if they're less educated than someone who just got the degree to just get it and they want to ride on the laurels of that degree, but they're not willing to learn more or work, just learn more about the things that they're working on or working with. And that's the biggest thing for sure.
Okay, a curiosity. Yeah.
One more thing, in addition to that, learning how to break things down in terms of literal things that you're working with your hands and problems um, that you deal with.
Okay. So breaking things down with your hands. So in other words, are you referring to taking things apart, or just understanding how to break things down into its parts? A bit take break a big thing down into its parts.
Both.
Okay. Okay. And does a person need? Well, I'm certain mathematics takes a certain amount of practice for everyone. But a
Hmm.
person definitely, a young person will definitely need to expect a curriculum intensive that's intensive in mathematics and physics and the hard sciences.
Yeah, that's actually kind of what I was referring to when I was saying knowing how to break things down because in these math courses or courses that you're going to be going into and taking, you get a lot of complicated problems and what it takes to solve them isn't looking at it at a whole to know how to break it down and extract what you need. Because sometimes there's information there that is solely for the purpose of background but not necessarily solving problem. um, you need to know how to break it down and extract what you need from the problem so you can solve it. Solve it in small steps and bring it back together um, to come to that solution you need.
Okay. I think UFO Kamikaze One has summarized it here. He said the ability to simplify the complex is often the true sign of intellect. Okay.
Exactly.
All right, Nikel. Is there anything else you want to say?
No, nothing else.
Okay. Well, thank you once again. Thank you for volunteering and thank you for coming up. I'm going to go ahead and close out here.
Okay, then. Thank you for having me.
All right, and we're linked on LinkedIn, so I'll be keeping tabs on you, and I might ask you to come back at some
Mhm.
point.
Okay, yeah, no
Good
problem.
luck.
Hmm.
All right. Well, everyone, I'm going to go ahead and finish up here. Once again, this stream, this was Austin Camacho. He's there in the chat. This was his idea. He asked me, could you interview an electrical engineer? So I put out my trailer on LinkedIn, and Nickel, he responded. Now, what I gathered, and you guys probably gathered this as well, Nickel was a little earlier in his career. So I might go ahead and search for someone who's a little more advanced, um, more of someone who's a little more advanced as well, so we can get someone who's new in the field and someone who's a little more advanced and experienced, because I want to hear some more about the field myself after just hearing about the fact that you need a certification to be called a electrical engineer, quote unquote. So I'm going to wrap this up. It's almost 9 o'clock. I have to eat, and then I have to go into the office tomorrow. And I'm still not used to going into the office. Those days are long because I have to commute into the office. So I'm going to wrap this up. I have more interviews on the way from the LinkedIn space and also from my personal circle. I'm actually tentatively planning to go to Dallas at the end of July to interview the head of a technology firm. So I'm looking forward to that. I'll be going back to Dallas. But I have more interviews on the way. You guys don't want to sit and listen to me talk all the time, do you? Because I can sit and talk all the time if you let me. Anyhow, the Big Words LLC Newsletter. Please consider joining the Big Words LLC Newsletter. The link is in the description box below. There's a greeting, and then the subscription button is at the bottom, right there. And it's really, really easy. In addition to being a YouTube content creator, I am also a writer. So I have my hands in a bunch of different things here. And that's how I fill my time. Gold Professor says, good stream, Dr. Dunbar. I really appreciate your input and interview with your guest. Good sir. Peace to everyone in the chat as well, Gold Professor. All right, Gold Professor, I appreciate you being here as well. All right, everyone, until the next one, and I'll make an announcement when I do the next one, but there will be more guests and more interviews. So everyone, stay safe out there. If you're watching on the playback and you haven't subscribed, please like, share, and subscribe. And if you want to make a donation to the channel, my Cash App and PayPal are below in the description box. So everyone, you know how I end these things. As always, remember that your attitude determines your altitude. Take care, and I'll talk to you the next time. Bye-bye. And thank you, Austin, for asking me to do this one. If there are more requests, if there are specific things you all want to hear about, scientific disciplines, specific science stories, reach out to me. You can reach out to me here. Austin found me on LinkedIn. I'm on LinkedIn, but you can also email me directly at bigdiscuss76@bigwordsarepowerful.com. There's the Big Words blog site Facebook page. I'm also on Twitter and Instagram. I actually did a brief Instagram live making an announcement that I'd be doing this. And I did a brief TikTok. A lot of folks are going over to TikTok. So I did a brief TikTok video. I'm on TikTok as well. So you can find me pretty much everywhere. But if you have requests, let me know. Otherwise, I'm just going to run off things as I see them in the news and as I see fit. The ideas come to me and I do content. So, all right, everyone, enjoy the rest of your night. And I will talk to you the next time. Bye-bye.